Very good morning students. Welcome to the class of trigonometrics. Today we have taken one question of height and distance from trigonometry where a ladder rests against a wall. So if this is the wall, right, and the slanting line you can see over here is the ladder, right? If this is the ladder, I am saying the slanting line, right, and this is leaning against the wall, and this is the wall. Let's say A to B is our wall, right? So here this is wall, right? Now as you can see in the question, this ladder is making an angle alpha to the horizontal. So this is the angle alpha, right? Now this angle alpha is mentioned which the ladder is making with the horizontal, and if this is the point C and its foot is pulled away from the wall through a distance A, if this is the foot, the point C where the ladder is residing on the wall, on the ground, and that point is C, and that foot, the one end of the ladder, is pulled away from the wall, away from the wall. That means you are bringing the foot at a far distance, pulling it. So we are pulling it. So after pulling, we just moved the ladder foot from C to D, and this is, you can see into the question, this is pulled by distance A. So this is the distance A, CD, right? So I am showing the structure of ladder over here so that it becomes interesting, right? And as per the data we have taken from the question, this ladder is leaning on the wall, and this is when the foot is pulled away by A, the top one end of the another end of the ladder, it slides a distance B. So let's say A to E is that distance where the other end of the ladder, which is leaning on the wall, it slides down by a distance B, right? Now what will be the new position of ladder? This one, from D to E. From D to E the ladder just skids and it settles at position D to E. Now on the wall, the ladder is residing one end at E and on the ground is D. And what is the angle it makes after sliding? The angle it makes with the ground is beta. So this I have shown it over here. So this is all the question data which is given. Now from B to C, let's say it's Y, and from E to B or B to E, let's say it's H, right? We have assumed it, right? And let us assume the ladder length also. So I will write it, it will be L, a small l. Okay. Now so in triangle ABC, you can see it's a right angle triangle, right angled at B. So in triangle ABC, so what we need to prove, just you read the question, we need to prove cos alpha minus cos beta by sin beta minus sin alpha. So we just take the RHS and we put up the value of cos alpha, cos beta, sin alpha to bring to a value which will be equal to LHS, right? So in this way we will proceed. So if the ladder length is L, and then in triangle ABC we can write cos alpha as Y by L, base by height, base by hypotenuse, right? So that will be our cos alpha, Y by L, base by hypotenuse. Similarly sin alpha will be B plus H, right? B plus H by L. It's a simple trigonometrical ratio calculations, and I'm writing the values over here after seeing the figure, nothing else. And in triangle EBD, what is that triangle? That is formed when after the ladder slides, right? In triangle EBD you can see here cos beta, sin beta. So that value we need to take. So cos beta, what will be the value of cos beta? Again base by height. What is the base? Base is A plus Y, right? And height, not height, it's hypotenuse, it will be L. So cos beta will be A plus Y by L. Since the ladder length is constant, the hypotenuse is always constant, H. hypotenuse, capital H instead. So in triangle EBD, we can say cos beta as A plus Y by L, because A plus Y is the total base after skidding, and L, the length of the ladder, is always constant. That is our hypotenuse. And what is the value of sine beta? Sine beta will be height of the wall where the ladder resides, that is B plus H. Sine beta will be B plus H. No. It's not B plus H. It's wrong. So I just cancelled it. It's only H. You can see the length of height B, EB. EB is H. So it will be H by hypotenuse, that is L. That is always constant, the length of the ladder. So sine beta is H by L, right? So we just put up all these values of cos alpha, sin alpha, cos beta, sin beta into the RHS. So we are not taking here the LHS and going to RHS, but here we are taking the RHS and we will go to the LHS to prove it. So in the RHS, it's written cos alpha minus cos beta by sin beta minus sin alpha. This is the data which is given into the question, which we need to prove. This should be equal to the LHS, which is our A by B. So we have already derived all these values. Cos alpha, just put up all these values from above. Cos alpha we have put Y by L. Cos beta we put from above, that is A plus Y by L. Here, from here we have taken it, right? So cos alpha we have taken, cos beta we have taken, which is into the numerator, and into the denominator we have sin beta and sin alpha. So just put up the value of sin beta and sin alpha. So what is sin beta? You can see H by L. Just put up the value into the denominator, H by L in place of sin beta, and in place of sin alpha it's B plus H by L, right? So we just put up the values over here, right? You can see L is there in all the numbers, so it will be cancelled out. L in the denominator of all the 4 numbers will be cancelled out. Now we are left with what? Y minus A minus Y, because A plus Y will be multiplied with minus sign, and into the denominator we have H minus B minus H. You can see into the numerator Y will be cancelled out and H will be cancelled out, and this minus sign will be cancelled out from A and B, which is left finally. So we are left with A by B. Yes, we have proved what we need to. So this is our LHS, and in this way we have solved this question, right? So this is the LHS, hence we proved what is required and asked into the question. So thanks for watching. Just like and subscribe, students, and keep on learning. All the best. Bye bye.